Hello again with another example related to projectile motion. In this example, I have a scenario of a fireworks where it's saying during a fireworks display, a shell is shot into the air with an initial speed 70 meter per second at an angle 75 degrees above the horizontal, as the figure or the supported figure showing the scenario. Now the fuse is timed to ignite the shell just as it reaches the maximum height or the highest point above the ground. Now we need to calculate the height at which the shell explodes. That means it's the maximum height. And then we need to calculate how much time passed between the launching and the explosion. And then what is the horizontal displacement of the shell before or like when it explodes. That's mean the range. So as a start, when I look to the scenario here, I have a vector making an angle with the horizontal, which means as a start, I need to analyze the velocity of this vector into two components. So I will have the initial um, component or the horizontal velocity component, which is v cosine the 75 degrees. And if we do the math here to calculate this, it will give us, now I have cosine 75, it gives us 18.1. Okay, so here is 18.11 meter per second. Now for the Vy initial, it will be the V sine 75 degrees. Once again, we're going to calculate this, 75, and it will give us 67.61. 67.61, and it is meter per second. So now I know my Vx initial, which is a constant magnitude in the entire process, and I know how much is the Vy initial as a start with the y direction. Now, let's begin with trying to see if or how much these information will help me. To calculate the highest or the maximum height this shell will reach, I have to remember that I know at the maximum height, the Vy at the maximum height will equal 0. Now, I don't know what's the time, so I will think about other kinematics equation could help me, which is going to be the Vy final squared equal the Vy initial squared plus 2 gravity acceleration, and the height is y. Now, here it's 0, and the Vy initial, it's the one here we calculated. It's going to be 67.61, and it's all squared minus, because the gravity acceleration, but it's going to be 2 multiplied by 9.8, and the missing height, we need to work it out. Just by rearranging the formula and finding y, it will be, it's the 67.61 squared. Sorry, let's fix this a bit. Might help us to see things better. Anyway, it's 1 as squared and over the 9.8 times 2, which is 19.6. Now, when we do this on the math, it's going to be, let's see this one, 7.61 divided on 19. That will give us 233 meters above the ground. So that will be the maximum height this shell will be reaching before it explodes. Okay. Now, so we know our maximum height. Now let's go to the next step. How much time passed between the launching of the shell and the explosion? So this one is going to be one-way trip. So it's going to reach the maximum height and it's going to be explode. Once again, we're talking about a vertical motion, or like when I want to know the time upward. So I'm thinking about the y direction. So I will pick the Vy final equal the Vy initial plus the gravity acceleration multiplied by the time. Now I know at the maximum height the velocity will be 0. For the y component, for the y initial, we have it, it's 67.61 and minus 9.8 multiplied with the time. Now, very simple. We're just going to rearrange our formula. It's going to be 67.61 divided on a 9.8. Let's find how much is the time in this case. 67.61. And that will give me, it's about 6.9 seconds to reach the maximum height before it's explode. Okay. All right. Now let's go and find the third part. So we'll take this part all off now. I don't need this anymore. Okay. Now we need to find what is the horizontal displacement of the shell when it explodes. In other words, it's asking me to find how much is the range horizontally, or how far from the starting point on the x-axis or horizontally. So this way I will find the range, which is the Vx initial multiplied with the total time of the flight. Or in air. So the Vx component initial, here it is 18.11 multiplied with the time we just calculated, it's 6.9. And let's do this one. So 6.9. That will give us about 125 meter. That's the horizontal displacement of this shell from the launching point. Okay, I hope you find this video useful. We'll see you again with another one. Thank you.